All right, let's take a look at this question. Patel Singh had hoped his crops would get 3 3/8 inches of rain. The newspaper said it would only get 3.3. Okay, what was that more or less of what Patel had hoped for, and by how much? So we know we have to subtract, but we also have to compare them. Okay, in order to compare fractions and decimals, they either have to all be fractions or all be decimals. Now listen, we already know how to change this decimal to a fraction. That's, I hope you know, because we just did a couple lessons like that. That's 3 3/10, right? 3 and 3 over 10. So that's not bad. We have not learned yet how to change this, a fraction, to a decimal. So let's do that, just so we know how to do it. There's two ways we can do it. We can either change this to an improper fraction and change that type of fraction to a decimal, or we can just do this, say 3 plus whatever 3/8 is. So I'm going to do it that way. I just think that's a little easier, but it does not matter. I'll do it both ways if you need to see it. Okay, let's take 3/8. This means 3 divided by 8. So I'm going to go 3 divided by 8. All right? That 8 stays outside. I'm dividing into 3. There's your decimal. 8 does not go into 3, so I need a 0. Okay. 8 goes into 30 3 times. Oh, there's my point. 8 goes into 30 3 times. 8 times 3 is 24. I'm going to subtract, but I can't have a remainder. I'm going to add a 0. 8 into 60 is 7. 8 times 7 is 56. Subtract, I get a 4. Add a 0, bring it down. 40 divided by 8 is 5, and that's a beauty because that's 40. So this is 0.375. Now, here's the deal. Remember how to add. This is 3 point, and this is 0.375. I'm adding the 3 plus the 0.375. Don't forget to line up your decimals. So this is 3.375. So that's what this is, 3.375. I just want you to see something because I feel like if I don't show you this, we're losing out. So watch this. Ready? What if I had done this? I'm going to do this a little quicker, maybe. What if I had done this? 8 times 3 is 24, plus 3 is 27. 27/8. Watch what would have happened. 8 goes into 27 3 times. 8 times 3 is 24. Subtract, you get 3. Add a 0. There's a decimal. 8 into 30 is 3. That's 24. That's 6. 8 into 60 is 7. Told you we'd go a little fast. We kind of just did this. 8 times 7 is 56. Subtract, we get 4. 0, bring it down. 8 into 40 is exactly 5. Notice you get the exact same answer. Whatever makes you happy. Some people like this because then they don't forget to add. You had to do an extra step when I did it. You had to add this together. So that's absolutely up to you. I don't care how you do it. Just know how to do it. Okay, so let's take a look at this. This is 3.3, and this is 3.375. We are comparing these decimals. Well, 3.3, if I'm going to compare, remember what we did before. We want them to have the same number of decimals. So there's 1, 2, 3. Here there's only 1. So I'm going to add 2 more decimals. So I have the same number of decimals. So we have 3,300, and we have 3,375. So this is less than that. Okay, so this is what the newspaper said. This is what Patel had wanted. So it was actually less than what Patel had hoped for. But it wants to know by how much. Okay? By how much? How much of the difference? That means we're going to have to subtract. Remember to always put the bigger number on top. So 3.375 minus 3.3. I'm going to put the zeros in as a placeholder. Now we're just going to subtract. We're going to see by how much. 5 minus 0 is 5. 7 minus 0 is 7. This is 0. So by 75 thousandths of an inch. Okay? And that takes care of that problem. All right, I'm going to check something for you in just a minute. Let's look at, look, we went from here to here. If we went from here to here, can we now take this and get back? Just a little FYI. You're done with the problem. I just want to show you something. Oops. 3.375. Let's say you have the decimal. We recall how to get back to the fraction. We did this before in a previous lesson. This is 3 and 375 thousandths. So it's 375 thousandths. All I have to do here is reduce. So watch this. I'll reduce by 25. If I reduce by 25, I get 4 for every 4, 8, 12, 15. 15 over 40. Not done because I can still reduce. Let's reduce by 5. And I get 3 and 3/8. And I can get back. So I can always get back and forth. How do I get from a fraction to a decimal? I divide. How do I get from a decimal to a fraction? I use the fact that I know this is the tens, hundreds, thousands place that I can use a power of 10. Okay? Again, in order to compare them, they have to be in the same form, either all decimals or all fractions. Okay. So let's look at this set of examples. There are 6 of them. We're going to change them all to decimals, and then we're going to state if they're repeating, terminating, or non-repeating, non-terminating. Here we go. Number 1. 2/5. We want to change that to a decimal. Let's remember how to do that. That just means 2 divided by 5. So 5 does not go into 2, so there's your 0. But now I need a 0 here. 5 goes into 24 times. So 2/5 is the same as 0.4 or just 0.4. And that is a terminating decimal. Why is it terminating? Because it ends. You remember the terminator? Terminator? He ends your life. Terminating decimals means it ends. Okay? Let's look at 1/3, my favorite. 1/3. 1/3 means 1 divided by 3. There's your point. 3 doesn't go into 1. 3 goes into 10 3 times. Multiply, we get 9. 10 minus 9 is 1. Let's do it again. Oh, we get it again. We get 3. Uh-oh, we get it again. We're going to be here all day. So it's 0.3. It's just going to keep going and going and going and going. Okay? So we want to round it to the nearest thousand, it says. So 0.333. The next number is going to be 3. Why do I want that? I need that to round it to the nearest thousand. I look at that. It's not a 5 or higher. So it's going to be 0.333 rounded to the nearest thousand. But we classify it. It says to classify it as repeating or non-repeating, non-terminating, or terminating. This is clearly a repeating decimal. This is it rounded, but this is a repeating decimal. You know which answer we're never going to get here? Think about it. The answer you're never going to get here is non-repeating, non-terminating, because they can't be written as fractions, and you got all fractions there. Remember, a fraction is any number that the numerator and denominator have to be an integer, and the denominator cannot be 0. So you're never going to get the answer non-repeating, non-terminating, or it wouldn't have started as a fraction. Pretty cool. All right, so let's look at number 3. We know it's negative, so that's okay. We'll just deal with a fraction right now. 17/20ths. Bring the point up. 20 does not go into 17 if you'd like to write that 0. 20 goes into 178 times. That's 160. Subtract. We get 10. I'm feeling good here. I'm showing you. I'll tell you why I'm feeling good. Watch this. Okay, add the 0. 20 into 100. I know that. I know that can happen real easy. 20 goes into 105 times, and that's 100. No remainder. So it's negative 0.85, and that's a terminating decimal because it ends. Okay. 4 and 9/11ths. Ready? Here we go. I'm going to take care of just the 9/11ths, I think. It's 4 point whatever the 9/11ths is, right? So we're going to do 9/11ths. I like 11. It's easy. Okay. 11 doesn't go into 9, but 11 goes into 90 8 times. That's 88. Remainder 2. Got to add a 0. Can't have a remainder with a decimal. 11 into 20 goes once. That's 9. Add the 0. 11 into 90 goes 8. Oh, I see something going on here. Hope you see it. That's 88. Remainder 2. 0. Here we go again. 11 into 1. So here's what's going on here. This is actually 0.81. It's going to repeat. But what does it want us to do? It wants us rounded to the nearest thousandths. So tenths, hundredths, thousandths. So here's what I got. Let me erase this because it's really getting kind of ugly on this board. 0.81, 0.81. Okay. So it's 0.8181. Thousandths is here. Tenths, hundredths, thousandths. I look at this. I leave that alone. So it's approximately 0.818. 4.818. They want to know what kind of decimal it is. So repeating decimal, because we're going to keep getting 81, 81, 81. So it's a repeating decimal. Okay. Last one. I can do this. -3 and 7/10. Done. So cool. I didn't have to do anything because I know that a decimal, right away we can write it as a decimal if its denominator is a power of 10. Beautiful, beautiful, loving that. And it is a terminating decimal. Awesome. Last one, 1/2. You probably know what this one is already, but we're going to play anyway. Here we go. 1/2. Get all the extra markings off the board. All right, 1/2. 2 does not go into 1, so there's your 0. Now we got to add a 0. 2, oh, I'm loving this. 0.5, 0.5 or 0.5. Think of a half of a dollar. Okay, 0.5, and this is a terminating decimal. So awesome. Done. Okay, I'm going to show you something that I hope when you're done, you're either going to say that was stupid or that is so cool. Okay, let's watch. We just did 1/3 and we got that repeating decimal. I'm going to write it with a bar over it. Remember, a bar is to be exact, tell you exactly what you got. Well, from there, I should be able to tell what 2/3 is. I should be able to tell what 3/3 is. Okay, here's the deal. I just want to show you something. 2/3. 2/3 is really 2 times 1/3. That's 2/3. So this should be double this. If I have 1/3 and another third, I get 2/3. So this should be double this. So this should be 0.6. And now 3/3, oh, bar. Now 3/3 should be 0.9 with a bar. Now let's talk about this. This bar tells me it's going to repeat and repeat and repeat. We know 3/3 is really 1. That's exactly what 3/3 is. Why does this happen? Because this is a repeating decimal. Repeating decimals are, when you work with them, they are not as exact as fractions. When you have a repeating decimal, you really want to work with a fraction instead. So when you're going to multiply or divide or add or subtract, you don't really want to round this and use the number. You really want to use the 1/3. The only numbers, the only kind of decimals you really want to use in addition, subtraction, multiplication, or division are terminating decimals because they are exact. So when people say, I hate fractions, well, and we just did circumference of a circle, if you were building something circular, okay, and you had a repeating decimal, you much rather use the fraction than the rounded decimal because you might have a hole, okay, with nothing in it. So you have to be really careful about decimals that do not terminate. All right, so let's look at this next one. 1/5, 2/5, 3/5, 4/5, 5/5. Watch what happens here. I gave you that this is 0.4, which you already knew. We did this one already today, I think. Okay, so that's 0.4. Well, 2/5 is double 1/5. So if this is 0.4, this has got to be 0.2. If I double 0.2, I'll get 0.4. Well, 3/5 is 3 times 1/5, right? Watch. 3 times 1/5 is 3/5. So it's 3 times 1/5, which is 3 times this, or 0.6. Guess what the deal is here. 4 times 1/5. 4 times 0.2 is 0.8, and 5 times 0.2 is your 1. Why is that exact there? Why is that exactly what it should be? Because 0.4, 0.2, these are all terminating decimals. So awesome. That is so awesome. You don't know. Okay, let's see why we care about any of this. Let's take a look at an example. The next example is about an artificial heart valve. If you were the receiver of the artificial heart valve, you might care about this. Here we go. It says, Precision Medical Parts makes an artificial heart valve that must measure between, okay, so this heart valve must measure between 0.998 centimeters and 1.002 centimeters. You want to know the lengths that are acceptable. So the first length you have is 1.01. So you want to know if that length is acceptable. So you're trying to tell if that length is between these two lengths. Again, we're comparing these decimals, so we're going to get them to have the same number of decimal places. This has 3 decimals, this has 3 decimals, but this has 2 decimal places. So I'm going to add a 0, and I'm going to think of this as 1,010. I'm going to think of this as 998. I'm going to think of this as 1,002. Is 1,010 between 998 and 1,002? Nope. So the first one is no good. 1.01, no good. Let's try 0.9991. 0.9991. Okay, that's 4 decimal places. Well, let's make these guys have 4 decimal places. So I'm going to take 998 and add a 0. I'm going to take 1.002 and add a 0. Now it's 4 decimal places. This is like the number 9,980. This is like the number 10,020. Whoops. 10,020. Okay. Is this number 9,000? This is like the number 9,991. Is this number somewhere between these two numbers? That answer is yes. So that one's acceptable. 0.9991 is a winner. Okay, you try the next 2, and we'll see if we match up. Okay, now we got 2 more, right? Let's see how you did with those. We have 1.0007, so that's 4 places. So I need 4 places here. Let's add some zeros. Okay, I'm looking for my pen. Here we go. Got it. All right, so 4 zeros. 4 places. There's another place. This needs another one too. So this is the number. Think of this as the number 9,980, and this as the number 10,020. And now think of this as the number 10,007. Okay? Is 10,007 somewhere between these two numbers? And that answer is yes, so that's acceptable. 1.0007, this is my acceptable list. There's one more, 0.99. Okay, so remember this started like that. This started like that. And we have 0.99. Okay. Well, this only has 2 places, but these have 3, so I have to take this one to a 3rd place. Think of this as 998. Think of this as 1,002. Think of this as 990. Is 990 somewhere between these two? And that answer is absolutely not. So that's a no. So 0.99 is no way. So these are the acceptable lengths for the heart valves. Okay, so I think it's really simple if you just give them the same amount of decimal places, all right? Let's take a look at this next one. We want to arrange from smallest to largest. The one little thing we have to do here is notice there are 3 decimals and 1 fraction. We're going to have to change that fraction to decimals, unless you want to change all the decimal fractions. I'd rather not, because if we change all the decimals to fractions, we then have to make sure they have the same denominator, because the only way to compare fractions is if they have the same denominator. So I'd rather not do that. So let's compare the decimals. Before we do that, I'm going to change 1/20th to a decimal. So let's take 1/20th. 20 does not go into 10, but oh, beautiful! But it does go into 100 5 exact times. So 1/20th is the decimal 0.05. The other decimals you have there is 0.043, 0.051, 0.006. Okay, so let's compare these. They all have 3 decimals, so I'm going to give this a 3rd decimal. So this is the number 6. So smallest, that's it's not the number 6. Let's think of it as the number 6. It is the number 6 thousandths. Okay, so 0.006 is the smallest. The next smallest is this one, 0.043, because we can think of it as 43. And then this one, 0.050. And then finally, the biggest one, 0.051. And that's it, from smallest to largest. And the next question, you want to use the inequality. Remember, is less than, is equal to, or is greater than to compare the decimals and fractions there. Again, I would convert all the fractions, and some of them we've already done, so we'll talk about that. Okay, some of them we've already done, and we want to compare them. So take a second to do that. Okay, now listen, part of my job is to teach you and to be able to be around if you have questions. The other part is to make you an independent thinker, so we're going to let you do that for a minute. We've already done 1/2. 1/2 is 0.5. We've done that earlier. So let's look at 1/2 as 0.5, and now this. Think about what this really is. This is 0.5555555. So I at least put 2 down. Put 1 more than you already have here, because otherwise it just looks like it's 0.5 and you can't compare it correctly. Now add a 0 to this and compare them this way, and we got is less than, because 0.50, or 50 if you want to think of it as that, is less than 55. Okay? That's 0.50000. That's 0.555555555. So that's is less than. So you got to go 1 more place than this goes. However many places this goes, go 1 more with the repeating decimal. Okay? All right. Let's think about this one. We've already done this one, because 2/6 is the same as 1/3. If I reduce this fraction, divide by 2, divide by 2, I get 1/3. 1/3, you remember, is 0.3 with the bar. It's 0.3. Okay. All right. And this is 0.333. This is a terminating decimal. I know it looks like they stuttered, but they stopped. Okay? This never, ever ends. There's no dot, dot, dot here, so this ends. So if this goes 3 places, guess how many places we're going to bring that to? Yes, 1 more place. So we're going to do 0.3333. Bring it 4 places. Add your zeros. Think of this as 3,333. Think of this as 3,330. That makes this is greater than. So this is greater than that. So the is greater than symbol goes here. So the is less than symbol goes here. The is greater than symbol goes here. Now, I'm going to show you something really cool. Really cool. 1 second ago, we did, well, maybe not 1 second ago, but before, in our last examples, we did 1/20th is 0.05. If 1/20th is 0.05, we want 3/20ths. Let's think about the connection between 1/20th and 3/20ths. Well, 3/20ths is 3 times 1/20th. So I can just do 3 times this. 3 times that is 0.15. If you don't believe me, you can do the division. But that's 0.15. So let's put that up there. Is 0.1501, 0.15. Give it the same number of decimal places, so 4. Think of this as 1,501, 1,500. This is greater than. So the is greater than symbol goes there. So take some of what you learned and be able to apply it. Well, if I have 2/6, I have 1/3. If I have 1/20th, I have 3/20ths, or I have 5/20ths. So make sure you can take it and move along that way. And that's the end of fractions and decimals. The next thing we're going to do is, catch this, applications of fractions and decimals.